is asking us to merge two binary trees. So basically, as an input, we would have two trees that we see here, one on the left, one on the right. And as an output, we should return a new tree, or a merge tree, which is basically the union of these two trees. So let's go to the iPad to see it in more details. Yep. So what you see here, this is tree 1. What we have on the left, this is tree 1, let's call it T1, and here is tree 2, and this is the output. And what we should do is every node, we check, okay, this node is already in both sides, then we add the summation as the output. So here you see it as 1, here's 2, so the output is 3. Same here, we go at this point here, we find here on the left is 3, here it's 1, so the summation is 4. On the right it's 2, here 3, so it's 5. And notice here, so when there's on the top left, it exists here, but it doesn't exist in the tree T2, this branch here, this node 5. What we do, we just add it there. Same with the other side. This node 4 exists in the T2, but not at T1. We add it there, and so forth and so on. So you can just think of it abstracted to two things. If the node exists in both trees, the output node is the summation of both. If it does not exist in any of them, then you add it to the output. That is exactly what we will do. So let's go to the question again to check what's the input. So the input you get as an array here. You get the node of T1 and you get the node of T2, and the output should be the combined one or the new one. So let's go through the code and try to exactly think what we will do. But before I show you the code, let's just think about it in English. So what we want to do is at every step, check if node, so let's type it in new lines to make it easy. So what we need to check, 1, if node exists in both trees, so T1 and T2, add both values to the new node, to the new tree node. That's case 1. Case 2, if node exists in T1 but not in T2, add node to the output, or let's call it the T0, which is the output. T0. Same here, but the other way around. So if it not exists in T2 but exists in T1, then you add that node to there. That's exactly what we will do in code. So let's check. Our code is pretty simple. We have here, that's the signature. We get the two nodes of both trees as an input. What we do at every step is we check, first of all, is this tree, I mean, this is just an edge case. If none of the trees, it's a null and null, then we return null. However, this is here what we just described above. If the root one, if the value at T1 is not existent, then we return the value of T2, and the other way around. If the value at T2 is not existent, we return the value at T1. And if we're here, that means that, okay, at this point, they're both there. The value, the same value, or the same place at T1 is also existent, and the same place at T2. So what we do there, we just combine or add up both of their values to combine and have the new node. And at this new node, we just say the same. What will be the left? We go to the left. And for the right, we also go for both trees on the right. And that's it. Very simple, very straightforward. Let's try to check the time complexity. So the time complexity here would be that we go through both nodes. So we're going through the T1 and the T2 nodes. You can also think of it as going for the biggest tree, but let's just simplify it and say that time complexity, so here's the space, complexity, would be O of number of nodes. Let's say n, where n is the total T1 3.1 and T2 3.2. Space complexity is, it's only the stack trace that we have to get. And as you know, the stack trace of binary tree is usually O of the depth, yeah, where D is the depth of the binary tree. That's the output, and I think in most cases you can say this is O of log n, but let's just check again the solution to make sure we got this correctly. Okay, so time complexity, yeah, is the nodal node to be traversed, and the space complexity is the depth of the recursion tree, which again, as I said, is usually log of m, which is m's number of nodes. Yep, so that's simply it. And here was the results when I ran it. Yeah, the algorithm is pretty straightforward, and I hope it was clear.